All right, guys, this is the picture and data section of the lecture, chapter 11, section 2. And in this section, we're going to focus on three types of graphs that can help us picture our data, which is going to be a histogram, a frequency polygon, and then we're going to focus on pie charts. Now, what is a histogram? A histogram is the most common type that we're going to use. A histogram is a graph that displays data by using contiguous vertical bars, unless the frequency of a class is 0, of various heights to represent the frequencies of the class. It's a bar graph, basically. So what we're going to do is, for number 10, we're going to construct a histogram using the frequency distribution in question 7. Okay, question 7 was my test scores. So what I'm going to do is, we're going to draw a bar graph. But in this case, the bars will touch each other. Okay, let's put that here. Y, X. So label your axes, X-axis, Y-axis. The X-axis is going to be the classes. In this case, the test scores. The Y-axis will be the frequencies. Now, going back to that example that we did for number 7, the highest frequency is 5. So let's zoom in a little bit. This can go up to 6. So I'll put 3 right here. 1, 2, 4, 5. Okay. And my classes consist of 75 to 78, 79 to 82, 83 to 86, 87 to 90. And now we're going to draw vertical bars that represents the height of this frequency. So 4, 4, 5, and 3. Let's remember that for the frequency of those classes. So the first bar will have a height of 4. Now, I'm no good at drawing graphs. So there we go. Let me draw this a little bit more thicker. Put a 4 right there. The next class, 79 to 82, also has a height of 4. So that doesn't change. Let's try that again. '83 to 86 had a frequency of 5. So that's gone up to 5. Is that a good approximation? Let's actually do that a little bit better. And the last one has a frequency of 3. And yes, I know I didn't measure 4 correctly, so please forgive me. Don't kill me. And that is your histogram. That's it. Okay, let's move on to number 11. Now, number 11 says complete the following, and it's also another histogram question. Now, when it comes to constructing a histogram, you can find the width, which is the distance between each class, by using this method. Finding the width of classes, you can find the width by dividing the range by the number of classes. You can find the width by dividing the range of your data by the number of classes we want. For number 11, it says draw the histogram for these following data using an initial class boundary of 20.5 and an ending with 44.5 with 6 classes. Note, you can add and remove classes in the figure. There's no figure. I just took this question from Alex. And you want to label each class with its endpoints. Okay. So, once again, to create a histogram, we must create some sort of bar graph. And it says here, the initial class boundary, the initial boundary from when I draw my histogram is 20.5. It ends with 44.5, and there are 6 classes. So let me start constructing my histogram down below. Now remember, the y-axis for the histogram is the frequencies. The x is the class, or my classes. In this case, the boundaries. So it says the lowest value, the initial boundary is 20.5. So I'm going to put 20.5 right here. And the highest is 44.5. And we want to have 6 classes. One, two, three, four, five, 6. Okay, 6 classes. I need to find the rest of these boundaries down here. How can I do that? I need to find the width, which is the distance between each class. So for me to do that, I'm going to follow the format. I'm going to follow the definition that I gave you right here. You can find the width by dividing the range by the number of classes. The range of my data set, the range is the highest value minus the lowest value. Well, look here. We are starting with 20.5 and we're ending with 44.5. So to find my range, that is going to be 44.5 minus 20.5. Which means the range is going to be 24. Now, I want to find the width. The width, as I said in the definition that I gave you, is equal to the division between the range and the number of classes. W for short for width. The range is 24. We have 6 classes, because we want to have 6 classes. 24 divided by 6 is 4. So that means the distance between each class is 4 units. If my first class starts at 20.5 and I apply my width, that means the second class is 20.5 plus 4, which is 24.5. Then the next one is 28.5. If I keep adding 4, 32.5, 36.5, 40.5. And if I add 4 to 40.5, we get 44.5. And those are my boundaries. Now, let's look at our data set. And let me draw my frequency. I'll put the highest here as 8. Now, let's see how many data values will be in between 20.5 and 24.5. And these are class boundaries, not limits. Don't confuse the two. Between 20.5 and 24.5, let's see. That's 1, 2, 3, 4. 4 data values between 20.5 and 24.5. So I'm going to draw my height up to 4. Between 24.5 and 28.5. 1, 2, 3, 4, 5, and 6. And I noticed I made a mistake for the first one, because my counting is not always the best. But there are actually 5 values between 20.5 and 24.5. That is 23, 22, 24, 24, and 21. How did I miss that? Trust me, I do not know. So it's easy to make a mistake like I did there. I'm going to leave that in the video. I'm not going to edit that out. Okay, is that it? Okay, between 28.5 and 32.5. 1, 2, 3. Apparently that is only 3. 32.5 and 36.5. 1 data value. Between 36.5 and 40.5. 1. Only, that's 1 again. And between 40.5 and 44.5. 1 and 2. And then we double check. Let's double check that. Between 20.5 and 24.5, that's going to be 1, 2, 3, 4, 5. That's correct. Between 24.5 and 28.5, 1, 2, 3, 4, 5, and 6. There we go. That one right there. Between 28.5 and 32.5, that is 1, 2, and 3. Between 32.5 and 36.5, that's only going to be 1. Between 36.5 and 40.5, that's 1. Between 40.5 and 44.5, that's 2. All right, guys, that's it to the end of the video. I'm glad you enjoyed it. I'll see you soon. Take care.